So for addition, I'm going to add two fractions that have got related denominators. Okay. So not common, not the same, but related. And related denominators just mean that one of the denominators is a factor of the other denominator. So when they're related, you only really need to change one of the fractions to make it common with the other. But before I even talk about those things making common denominators, I'm going to show you how I would get the students to model their fractions. And I'm going to use fraction strips for this. You can use Cuisenaire if you want, but I'm going to use fraction strips because A, it's a different material to use, and B, I like to encourage the students to work with and understand how to partition and fold their papers so that they make their fractions. That's actually a really important skill for them to learn. So I'm going to need two paper strips here. I know that each of these paper strips are the same size, so they're going to represent my one. Each of these is one whole. So what I do is I start by folding one of the strips into the thirds and showing 2/3 and one into 6. So I get them to start with their first one. And there you have it. I got my 2/3 and I've got my 1/6. Now, important thing to note when students are labeling their fractions in any way, they label them as the fraction of each of the parts. So 1/3, 1/3, 1/3, rather than 1/3, 2/3. Okay, so I want you then to fold it and show 2/3 and show 1/6. So what we're really doing in this equation is we're adding 1/6 to 2/3. And if we compare it back to our whole, we can sort of see that it's less than over here. It's less than, a whole, obviously, but we don't know how much less because these two fractions are different in size. So when we're adding two fractions that are different sizes, we really struggle with how to actually process what the size is. So there's a couple of ways that students might look at this. They might look at this gap here and say, well, I actually think that that gap looks like it can fit another 1/6. Okay, and they would be right. This fraction is 1/6 away from one whole. So if we're 1/6 away from one whole, that means our total will be 5/6. Or they can think about how, if we were to really understand how many we have altogether, we can fold our fractions into the same number of parts. So we can actually say, instead of 2/3, I can partition into 6ths. Now I have 4/6. So I have 1/6, 1/6, 1/6, 1/6, and another 6th makes 5/6. So really, when you're working with adding fractions that have got different denominators, what you really want to get the students to understand is that I can change one of or both of the fractions and make the parts the same. And this is the reason why, because it's very hard to add two fraction parts when they're different sizes. So now I've changed this to 4/6. I've added 1/6, so common denominators. 4 plus 1 equals 5/6. And there you go. And if I was to show that on a number line, this is how I would do it. All right, so here's one that I prepared earlier. So you've got here, you can see that I have added my 2/3 first, and then I've added another 1/6. But if you can partition your number line into parts that we can see represent the two types of fractions, then if I was to work out the total of the position I land at, it is 1, 2, 3, 4, 5/6. And there you go, adding and subtracting fractions.